uh, 12 questions, but I'm counting it only out of 10. So if you get all 12, you get 12 out of 10. So hopefully we'll have a bunch of 12 out of 10s. So here we go. What this says, what is the end behavior of that curve? Okay, so think about what that curve looks like. And then remember, when you write end behavior, you must use your limit notation, right? So your answer is going to be, I'm going to squeeze it in right here. Your answer is going to be the limit as x approaches infinity of f of x, and the limit as x approaches negative infinity of f of x. Now, I've noticed on the practice tests that they'll often say, find the limit, or find the end behavior as x grows without bound, okay? So that would be x approaches infinity, right? I'm asking you for both of them. So tell me what you know about this guy right here. What do you know about him? He's odd, and he's negative. Starts up, ends down. So this guy looks like this. So, as x approaches infinity, we are going down. And as x approaches negative infinity, we're going up.
But how do you know which way it starts? Like, how do you know if it starts?
Odds are down up. Odds are down up. You gotta remember that.
Well, could it go like, what would one look like if it was started down, like it was going down and then ended up?
It would look just like that. And it
I know,
would be
but
a
like
positive x cubed.
Okay.
Positives start down, end up. So negatives are upside down with that. Right? Evens are up, up. Put a negative in front and they are down, down. All right, 1 minus 2 sine squared. That should ring a bell. What is 1 minus 2 sine squared? Cosine 2x. Got some unit circle questions here. What's the cosine of negative 5 pi over 3? You know this. You guys are really good at these, but it's negative 5 pi over 3. So it's going to be around, all the way around in quadrant 1, right? And that is 1/2. Everybody okay? Now be careful here. What is this one asking me for? The angle, whose cosine is negative 1/2. And we have to remember that inverse cosines are only defined or only exist up here. So if the cosine is negative, it's got to be here. That's the only choice you have. And if the cosine is negative 1/2, then it must be 2 pi over 3. So cosines are top half of the circle. Inverse cosines, I should say. And inverse sines and tangents are the right half of the circle. Tangent, 3 pi over 2. Undefined. Yep, undefined. If p of x is even, so p of x is some function, if it's an even function, and p of negative 4 is negative 7, what's p of positive 4? Negative 7. Because in even functions, changing the sign on the input does not change anything about the output. Right? 1 plus tangent squared. Secant squared. Very good, very good. What's cosecant by definition? Cosecant is 1 over sine. And there's another definition? R over y. Very, very good. Very good. All right, sine j, cosine A minus cosine j sine, that should be an A. That would be a tricky problem. What is that? Sine j minus A. Very, very good. Those are your sum and difference identities. R equals 5 sine 4 theta. That's a polar curve. Tell me what it looks like. Okay, it's a rose, and it has 8 leaves or petals, and they are each 5 long, right? find the amplitude, period, phase shift, vertical shift of this equation, all right? So what's the amplitude? Or, a lot of times they call that, A, B, C, D, right? So here we go, what's your A value out in front of the equation? What is that? 7. What's your period? Now be careful, your period's associated with that number, but that number is not the period. How do we find the period? 2 pi divided by that number. So your period will be 2 pi divided by 4, or pi over 2. What's your phase shift? Be really careful with this one. Before you can do your phase shift, you have to factor out that 4. So what's it gonna be? X minus pi over 36? So your phase shift is right pi over 36. Would you agree with that? And finally, your vertical shift is 2. Sometimes they call that the midline, right? Everything's lifted up 2. All right, so everybody clear on what's happening Monday? All right, okay, so tell me now, what are we doing in terms of problems? Let's make a list. Did you find any you need explained? Are we able to figure it all out looking at my hieroglyphics there? Yes.
71.
71. 9. All right, so 79, I got B, which I hope is right. I had so much fun taking these tests.
They were a lot of fun.
Oh, man, it was awesome. Just sat at the dining room table and just had so much fun. Alright, so the next one plane is back on the interval from 0 to 10. The point 3 negative 2 is on the graph. H of x. So we are looking at 2h of x minus 1. Okay? And we want to know which of those points is on it. So here's 3 negative 2. Whatever this thing looks like, that's on it. What do these modifications do to the picture? What does that do? Multiplies your y by 2? I just find it very odd that all these numbers are missing. What's going on? Okay. Oh, okay. Thanks, sorry about that.
Here's Mr. Hahn coming down the hallway right now.
Oh, good. Good. We got one. We're turning the flocks. I put out the old call. All right, so this multiplies the y's. So it's going to take this point and turn it into 3 negative 4. Does that make sense to you? Then what does that do?
Take it down.
Take it down one more, so it's going to take that point and become 3 negative 5?
Yeah.
Is that an option, I hope?
It is.
Yes. Okay, does that make sense to you? Remember, in the equation, thank you, in the equation, there are, just kind of here, these 4 things that we talked about. 2 of them impact x, and 2 of them impact y. Both of these are the y impact. If I want to impact x, I have to put a coefficient here and a plus or minus on there, and then that would take your x coordinate and move it. Does that make sense? Okay. Yeah.
Can you explain 27, please?
27. Well, let's see. I got D. What's it supposed to be? Let's look at it and see. I published the answers, Grace, if you want to check them out and see. Let's see. All right, so what's happening here? We have a data table given. Somebody did a linear model of that data, and somebody did a exponential model of the data, and then they constructed the regressions. Residual plots are shown, which is true. A linear model is more appropriate and residual plot one corresponds to the linear regression. Linear model is more appropriate, residual plot two, exponential model. Okay, now, take a look at the, oh, here's another one. The little ducks are returning to the flock, thank you. Okay, so, take a look at the data in the table. What's happening there? Can you tell what's happening? What's happening to the Y values?
They are,
Are they going up by the same amount? Are they, or I shouldn't say going up, are they changing by the same amount? Like adding one each time or adding,
it's,
we're multiplying. Okay, so stop. If we're multiplying, it isn't going to be linear, right? What are we multiplying by?
3 over.
3 over 2? And then 3 over 2, and then 3 over 2, and then 3 over 2? Isn't that giving us exactly the points in the table? So it's exponential, and which regression matches that? The second one. Because what does the second one say? If your residual is 0, what does that mean? Your data point matches the model exactly. And that's what happens. This is an exponential model, and every single data point is on the model. I mean, it fits the model exactly. So I don't know which answer that is. Exponent, is it C? D? Or, yeah, it's D. Yep. All right, who else? Yep. 82. I said C. Now let's see, what did I do? Polynomial function is an odd function with the domain. The table gives information about values of f of x and the behavior of the function. What is the absolute maximum value of f on its domain? Okay, so let's look at it and see what's happening.
On your key it says B.
It says what?
On the key it says B.
Which one am I doing?
82.
82. Oh, it says B. Oh, I'm looking at C. 83, I had C. Okay, well, let's just look at it and see what in the heck's going on. So this is -4 to 4. And it's an odd function. And I got 0, 0, and 1, -1, and 2, -3, 3, 0. I'm just plotting the points they gave me, and 4, 2. Does that make sense? Now, keep in mind, if it's an odd function, then when I put in -1, I'm gonna get the opposite of what I got when I put in +1. So -1, 1. 2 was -3, so -2 is gonna be +3. 3 was 0, so that one's gonna stay the same. And then what was this? That was 4, 2, so that's gonna be 4, -2. Does that make sense to you?
Yeah.
Okay, so what do I wanna know in the question? I wanna know the absolute maximum. The absolute maximum is right there. And that would be 3. All right, that makes sense to everybody? All right, anything else we need to talk about?
Can you do 87?
87. Let's see what I got. Oh geez, it looks like I wrote a lot. Let's look at it. 87. I got C. Let's see if that happens. All right, the function is defined, so it's an exponential. So here's my function. Oh geez, help me. Is that 0.0149?
It's negative.
Negative, thank you. Okay, did I get that copied right? Okay, and it says L of 0 is 15, so if I plug in 0, I get 15. And the limit as t approaches infinity is 1. And then I want to find where L of t is 6. Alright, so let's look at what we know here. Obviously, if I want to know where L of t is 6, I wish I knew what L of t was, and then I could set it equal to 6 and solve. This is a calculator problem, right? So I could even do it with like intersection or something. But I need to figure out what that equation is first. So keep in mind that this is exponential. What do you remember about just a standard old exponential, a b to the x? What do you remember about its shape? It is like this, right? Yeah. Now, what happens when, excuse me, when you make the exponent negative? Do you remember what that does? Changing the sign on x would reflect you across the y-axis. So instead of being a growth, it would be a decay. Do I know anything? No. Okay. Well, yeah, I know my base is positive. That's 2.718. So now my equation is going to look like this, just in general, if the exponent's negative. Okay? So I got a thing shrinking like that, but I'm moving it up b. So if I move that up b, I got like an asymptote here at b, and it looks like this. Would you agree with that?
Yeah.
Okay. This asymptote is the limit as t approaches infinity. Would you agree with me? So since I know the limit as t approaches infinity is 1, don't I know b has to be 1? The limit of an exponential is that asymptote. Digest it. Does that make sense? Now that we're talking about it? Okay, so now I know b is 1. If I plug in 0, I'm supposed to get 15. So 15 equals a e to the negative 0.0149 times 0 plus 1. Right? Well, what's anything to the 0?
1.
So 15 equals a plus 1, so it looks like a equals 14. So my equation is y equals 14 e to the negative 0.0149t plus 1. There's your equation. And you want to know where it equals 6? So I would just graph them both.
Okay.
And see what it cross. What? Did I make a mistake? You could also solve this. Just put a 6 here. Subtract 1, divide by 14, ln both sides. You could do it that way too. It looks like that's what I did on the key. I solved it with logarithms. Doesn't matter though. Doesn't matter one bit. Okay? All right, you guys are overwhelmed, overworked. You have a lot going on. So I'm going to go ahead and hand out both parts of the sample test. You have the rest of the period to work on the pre-response. Okay? That's your homework for Monday, is the free response. If you get it done in class, that's great. I know you got AP exams coming up next week, and I get it, I totally get it. This one is the most important one. Let's not lose sight of that. But I get that you have a lot going on. So.